Hello, good evening, friends. This is Surendra, and in last video we have done the MUX as a universal gate. So we implemented all the gates using MUX, and in this video we are going to start the identification of logic implemented by MUX. So we will see in question they will give some MUX, and then we have to check what is the output of that MUX. So I am taking the first example for this one. So guys, this is the example for this one. So first write the boolean expression for this one. So for this for 0, a bar b bar into c bar, a bar b bar into c bar plus a bar, sorry, 0 1. So a bar b into 1, a bar b into 1 plus this is a b bar into 0, a b bar into 0 plus a b into c bar, a b into c bar. So this will become 0. So then we have to minimize this function using kmap, or you can also minimize directly. So I'm minimizing using kmap. So firstly, like this is the kmap a b c 0 0 0 1 1 1 1 0 0 1. So you have to write a bar, so a bar is 0 and b bar c bar, so this so minterm is this one, and then a bar means 0, then a bar and b means this should not be changed, so this one and this one, and then this one is 0, a into b c bar, a into b c bar. These are the minterms so for this one. Then you can so we can make the pairs for this one, and this one. So for this one, what will be the equations? This will be y is equal to bc bar. For this one, a bar into b plus a bar into b plus, for this one this is not changing, so c bar into a bar, a bar into c bar. So this is the final equation for this one. We will take the another example. So guys, this is the another example. So how we will write the expression? Y is equal to a bar b bar into c, a bar b bar into c plus 0 1 means 0 means a bar b into c bar, a bar b into c bar plus 1 0 a b bar c bar, a b bar c bar plus a b c. So implement using kmap. This is a b c 0 0 0 1 1 1 1 0 0 1. So for a bar means 0, and b bar c means this one, and a bar b c bar a bar, and for this one a b bar c bar, this one, and for this one a b c means this one. A B C, so not this one, a b c. So this is the KMF for this one, and we have to solve this one. So we know that this is the diagonal adjacency, so we can't solve the diagonal adjacency. So this is the expression for, we know that I have proved in full adder. So AX or BX or C. Or if you want to see, then we will go little faster and we will see that a bar b bar, I am writing same expression, plus ABC plus a bar b c bar plus a b bar c bar. So from here take c common, from here take c bar common. So I am just for proving this one, a bar b bar plus ab into c plus a bar b plus ab bar and c bar. So this is nothing but XOR, XNOR, and this is XOR. So this is what? XNOR. So A XOR in bar B into C plus A XOR B into C bar. This is nothing but A bar into B plus A B bar. So the resultant expression is A XOR B XOR C. This is one terminal, like suppose this is the, like that, this is AB, this will be A XOR B, so this is AB A XOR B, and this is one terminal for XOR and C is another terminal. So this is the, like this is the expression for this one. So this will be A XOR B XOR C. Then we will go to the another problem. So guys, these are the another type of problems in which the uh, minterms will be given and you have to implement into MUX. So till now we have seen that you have given the problem like in MUX, and you have to see that what is the output and what is the output boolean expression for that one. So this is the reverse process as as we have seen in previous one. So they will give the minterms and we have to implement into MUX. So like suppose first example is like if a comma b comma c is equal to 0 comma 3 comma 6 comma 7. So this is the example for this one. So firstly we have to decide that which one is we are going to select as a select line. So suppose I am going to select these two as a select line. So see, so we have to write as I have explained when we were implementing gate using MUX. We have taken the same problem, that which one we are going to as a select line we will write here. So I am writing A, B and here C. So this is 0 0 0 1 1 1 0. So we have to just write the minterms for this one. So what will be the minterms? G 0 0 0 0 0 1 0 0 1 0 is 2, 1 1 0 is 6, 1 0 0 is 4. As we have written that A is MSB and C is LSB, that's why I am taking firstly this one and then this one. And 0 0 1, this will be 1, 0 1 1, this will be 3 7, 5. So we have to write the minterms into in this problem. So 0 will be 1, 3, 6 and 7. So these are the minterms. So what I have said that we have to write C bar and C. So we have to miss in each and every, we have to multiply with respect to this one, and then add it to both. So 1 into C bar will be C bar, 0 into C will be 0. So 0 plus C bar will be C bar. So for this one C bar miss, this is the procedure, but just see that which one is one right here. If both are 1, write 1, because we know that C bar plus C is equal to 1. If both are 0, then write 0. So this is C bar is 1, here C is 1, here 1 because both are 1, here this will be 0. So you have to implement this thing into the MUX. So 0 1 2 3, you don't have to write just as it is. Here 0, this one is 0 0 0, this is 0 1 1, this one 1 1 3, this one is 2. So you will write C bar C 0 1. So this will be the implementation for the this one, and we have to follow the same thing into a whole, like all questions. So you I am giving the given some problem that implement the carry of full adder using MUX. So I am I'm giving the answer, match it. So this is AB. This will be 0 C C1. This is the answer for this one. And then, as we have discussed yesterday, that if we have to implement like n variable function, then we need to, like, in a different way, I am saying in a different way, if we have, as we know that we write mux into 2 to the power n raised to 1. So by using this one we can implement the all n variable function and sum of n plus 1 variable function using this one. Why I am saying sum of, because in other we need some not gate, like here we have seen that this one need not gate. But if you have to implement two variable function using 4 raised to 1, then you don't need to worry about anything, just write the truth table of that one, your output will be same. So this is the logic behind it. So guys, now I'm taking the next example, and we will see in different way. Like firstly I will take AB as a select line, then BC as a select line, then CH as select line. So see the function. The function is f is equal to summation of m and 2 comma 4 comma 6 comma 7. This is the, so firstly I am taking as AB as a select line. So first make the KMF for that one. So this is C, this is AB. So this is going to similar as 0 to 6 4. So I will not repeat this one. So this one is 2. So write here 1. This one is 4. So 4, where 4 is here 4. This one is 6. This one is 7. So we have mentioned all the thing 0 0 0 1 1 1 1 0 0 1. So what next? I have said that you have to like see here, so this is both are 0, this will be 0. What this will be? C bar. This will be 1 and this will be C bar. So you have implemented this one. How this will vary, I will say that you can do anything you can select as a select line, and this is AB, this is first is 0, second is C bar, third is, and this is 1, this is 1. This is how it will be. Then I will select next BC as a select line and A as a input variable. Sorry, so this is the function, and I have is that this is I have represented this one, and this one is like we have similarly done in previous problems. So guys, I have taken as an example this one, and I have mentioned here BC, and so I am taking as BC as a select line. So BC as a select line, so this is like too much easy to make, like 0 0 0 0 0 0 1 1 3 2 4 5 7 6. So you have to just put the midterms in this schema. So for 2 this will be 1, for 4 this will be 1, for 6 this will be 1, for 7 this will be 1. Then what we have to do here, similarly A bar and A, so this will be A, this will be 0, this will be A, this will be A plus A bar plus A, so 1. So you can implement you. So this is the MUX, this is B and C. Here firstly A, then 0, then 1, then A. So this is y 4 raised to 1. So we have implemented this one using like taken the select line as BC. Then now I will not write again question, but now I have to implement same function, taking as a AC as a select line. So here I will write A and C. Here what is the meaning of this one? This one that I am taking MSB in select line, and this one is LSB in select line. Like you understand that when 0 0 0 1, so this is like that. This is MSB 1 0 1 1. So this is MSB, this is LSB. So 0 1 0 0 0 1 1 1 1 0. So this is the challenging task to us, that how we will write midterms. So firstly A, then B, then C, all are 0, this will be 0. For this one A, B and C, this one is 1. For this one A, B and C, this is A1, B0, C1, so 1 0 1, this is 5. This is A, B and C, this is 4. This is A, B, C, so this is 2. This is A, B and C, so 3. This is A, B, C, 7, and this one is 6. Then put all the midterms into the K-map. So we know that 2 2 4 6 and 7. So this is B, so here will be B, here 0, B and 1. So this will be implement like 4 raised to 1, A and C, this is B, this is 0, this is B, this is 1. So this is the implementation for this one. So we have seen many problems, and I will give one more problem. as a 8 raised to 1 mux. So like the function is f a comma b comma c is equal to in terms of 1 2 4 7 using 8 raised to 1 mux. So here we know that the variable is 3 and here 2 to the power 3, so n value is also 3. So what I have said that you have to just copy the this minterms into that mux. So I will show how you have to write this. A is this one is A, this one B, this one C, 8 raised to 1 mux. So 0 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7. So here which minterms are present in this? Write 1 1 1 4 1 and 7, other are 0. So this will give the same expression as this function. So we have done with this one, and in I will give one more topic, one more concept. So, so guys, as we have seen the don't care. So here we are not pairing anything. So how, like if any question given some don't care in midterms, and how we will select that means how we have to use don't care. So if don't care are eliminating the inverters from your circuit, then you have to use as a 1, like means you have to try to eliminate inverters into the circuit. So take it as example that f a comma b comma c is equal to, so guys I have written this one. So like here they have given the midterms as 1 to 1 comma 2 comma 7 and the don't care as 3 comma 4 comma 6. So firstly write midterms. So here 1 2 and 7, this is midterms, and don't care as 3 4 and 6. So see that what is, like if we are using midterms only, so this is C, this is C because this is C bar and C, this is C. And here if we are using only one midterms, we are using don't care as 0, so this will be C bar. And if we are using don't care as 1, so this will be 1. So we will, because by using don't care we are eliminating the inverter, so we will use as a 1, so this will be 1. And here if we are using don't care as a 0, then this will be C. Or if we are using don't care as a 1, so this will be 1. So here you can use both, like you can use as a 0 or 1, means nothing will like going to create problem. So you can use as a both, but here if we are using d as a 0, then this will be 0. If we are using d as a 1, so this will be C bar. So we have to eliminate inverters, so we will use d as a 0. So this is the concept that we have to use don't care in a manner so that the inverters in the circuitry should be reduced. So we have to try to reduce the inverters. So I have completed all the topics regarding like any implementation of any boolean expression into the mux. So in next video we will see the demux, that is demultiplexer. So thank you for watching the video. If you found and the content is good, so please like the video and share with your friends. And if you have any doubt, then please comment on comment section. And if you are new in this channel, then subscribe the channel for new videos. So thank you very much.